I'd like to say thank you very much for every one of you for making this possible and inviting me over from the other side of the planet. Literally, this is where I live. Of course, not on the bridge, but I'm pretty close, I swear. I really love Istanbul. It's a really beautiful city, and I really recommend it to everyone, especially if you're a foodie like me. My full name is Serdar Dogruyol, but it's hard to pronounce, even for my family, so they just call me, literally, even my mom calls me Sedo. It's much more easier. Sedo it is, and this is me, and the thing on top of my head is something called fez, which is a quite old Ottoman era hat, and that's actually the logo of my web framework, which I'm going to talk about in a minute. So I'm a Rubyist for a long time. Has anyone ever used Ruby here? Cool. Okay. So I love Ruby. I've been a Rubyist for the last 10 years, doing a lot of stuff, writing production code, building highly available systems with it. And then I discovered Crystal back in 2014, which is probably when the project just started. And I've joined the Crystal core team back in 2018 after 4 years of hard work. And I'm a proud member of the core team. I'm also the creator of Kemal, which is a web framework for Crystal. Actually, if you are a Rubyist and if you know the Sinatra web framework, Kemal will make you feel at home. It's super easy to get started, and the DSL is pretty similar to Sinatra. And the thing is that I'm a polyglot. That's what is written in Japanese there. I speak multiple languages. I also dealt with a lot of programming languages too. That's me actually presenting in Japanese last month in Crystal Tokyo user group. I look really fat there. I don't like the picture, but yeah, you get the idea. It was fun, super fun. And Crystal, has anyone heard about it? Oh, that's interesting. First things first, since I'm in the States, I'd like to talk about what's not Crystal. To be crystal clear, first thing is Crystal is not crystal meth. I don't know why, but whenever I talk from someone from the US, they are like, hey, Sedo, let's build a web framework called Crystal on meth. And I'm like, not again. So let's be clear. This presentation is about Crystal, not the meth, but the programming language. OK, cool. So what is Crystal? Actually, it's a programming language which can either be easy to understand by humans and compile to efficient, computer-friendly, fast-performing programs. So it's like win-win for both sides. And you might ask me why, like why another language? There are already people presenting languages here at this conference. But the thing is that, we love Ruby, which is a dynamic language, and we also want to have performance which is on par with C or C-level languages. So here you see that we love Ruby's efficiency, we love C's efficiency for running code, and TLDR is that we want best of both worlds. And also, I don't want to get rid of object-oriented programming. I like object-oriented programming, but yeah, I don't want to write C code just to get performance. And in dynamic languages, for example, in Ruby, if you are in dire need of performance, you turn to C, write some C code. For example, the Nokagiri game, which takes forever to compile, is written in C. But we don't want to do that. We just want to write Crystal to have both the performance and the productivity. And you might ask how we actually achieve that kind of things, like at the same time. So the idea is pretty simple. Just take Ruby and insert LLVM somewhere, and boom, you got it. But the reality is not that simple. Like Crystal has a compiler which generates LLVM IR code in the background and feeds that into LLVM. And then LLVM handles kind of the rest, like the targets, the compile time optimizations, and anything that's required. And that's like, this thing is coming up a lot. A lot of Ruby developers are like, is this a typed Ruby? No, it's not typed Ruby. Crystal is another language which looks a lot like Ruby, but it's not Ruby, or it's not a Ruby implementation. It's a different language by itself. So this meme was quite popular, I think last year or so, and you get the answer right. So let me talk a bit about the history of how it started. Actually, it's 7 years ago, a smart guy from Argentina, whose name is Ari, or Asterit, as you see in the first commit, is like, okay, let's do something fun, and let's mix Ruby and LLVM. So he pushed the first commit to GitHub. Then he really pushed a lot, churned out a lot of code. And 1 year later, he released the first version of Crystal, which is actually written in Ruby. Like you can see from this picture that this is all right, like a Ruby project. You see the rspec folder, you see the gem file, which is a typical Ruby library structure. So the first version was in Ruby, which makes a lot of sense because you want to create a Ruby-like language. You know Ruby well, why not do it in Ruby? But the thing is that Ruby is not so fast at runtime. So you have to give on performance. And if you're writing something, a big program like a compiler, which is itself at around 50K line of code, then it gets worse. So you kind of have to figure out a smart way to get rid of Ruby. And how you do that? That leads to something interesting called self-hosted. So, and if a language is self-hosted, that's a big achievement in itself. Like being self-hosted means a language is written in the same language as itself. Like Crystal is now written in Crystal, and you might be wondering how you actually do that. The thing is that you just start writing in some other language, and you replace the parts each by each when you have that feature in your own language. And when you get the 99%, you just get rid of that remaining part with the previous compiler. Boom, you have a self-hosted language. But to do that, you of course have to have a specification, at least in your mind, so that you know what you're doing. So here you can see that, I think this is from last year or this year, the repository, the Crystal main repository is like nearly 100% Crystal. You can ignore the rest. And, sorry, I was just, the thing is that why this is important, because if you know the language, you can directly contribute back to the language itself. Like, you don't have to be super smart to send a patch into the standard library. For example, you can fix a typo, or you can improve the documentation, or you can add a feature to the HTTP library in the standard library. Knowing that is, super encouraging, and that's how I started contributing back to Crystal. Like, I felt like, okay, I could do something. How about I opened the SDD and see where I can contribute back to. And then eventually you can contribute back to compiler and the parser, and so. Fast forward to today, after that time, Crystal is going actually pretty good. It gained a lot of traction. And as you can see, we have more than 250 contributors from all around the world. We have more than 13K stars on GitHub. Actually, we have a lot of packages, like libraries. The ecosystem is blooming right now, close to 5K packages as of today. And the thing is that we rely on donations to develop the language because it's an open source project and we are not backed by a big company. I wish we did, but that's the truth. So we rely on your donations. And recently we are seeing tremendous growth. The thing is that finally, from the beginning of this year, we got a full-time developer just working on the core of the language, which is great. And the latest release is 0.29. So I'd like to show you this interesting map, as you can see. So I created this map from Google Analytics to see where people are accessing the Crystal website and also where they are coming from, kind of mixed them together. And as you can see, US has a big impact. Also Turkey, which I am living in, also has a big impact. And also you can see Japan and many other countries kind of, interested in the language and also contributing back, which is great. That's it about the history. So let's take a look at the features and see. Yep.
Scale from 1 to 47, right?
Yeah.
Who's in Kazakhstan that's using it?
Sorry?
Do you know the guy in Kazakhstan?
Kazakhstan? I think I know it.
You know him?
Yeah, I think because I'm, sorry. I'm really into the community, so I probably know every single person using it, including Kazakhstan, also in Japan and other parts of the world. Yeah, I'm proud of it. Yeah, we just don't have North Korea yet, but that's TBD. Okay, let's talk about the features and see how we are doing, like what we are offering. The first thing is that being human-friendly, so Crystal syntax is heavily inspired by Ruby's, so it feels, for English-speaking person, it feels natural to read and easy to write, and has the added benefit of low learning curve for a Rubyist. Especially for experienced senior people, it's super easy to pick up, and you are really productive from day one, which is a great thing if you kind of have a Ruby shop. So that's like the simplest thing you do with Crystal or with any language, like printing out some stuff, and this is it. Like this is pretty much the same in Ruby. You can compile this code, run this code both in Ruby and Crystal, but again, Crystal is not Ruby. And Ruby is not Crystal. And again, for example, this is how you use Kemal, my web framework. Just 5 lines to spawn a web server, which also supports WebSockets and all the REST actions that you can think of. And for the Rubyist people, you already know that this is like Sinatra, right? So super easy to use. And its batteries included. It's not Rails, it's a micro framework, but it gets the job done in a pretty good way, and a lot of companies and users are already using this Kemal in production. Crystal has a strong type system, so it's static the type check. So any type errors or any errors will be caught early by the compiler at compile time rather than runtime. Like what I mean by that is that when you're working with dynamic languages, you mostly get runtime errors out of nowhere. With Crystal, this is like the compiler covers you, and it's pretty much like other languages where it's like if it compiles, it works. So let me show you what I mean by strong type system. You can't see the types here because the compiler is smart and it infers all the types if you want to. As you can see, these variables are all untyped and they have their types in the compiler automatically. So the first one is a char, the second is a string, number, float. And you can even create an array of all those types together, which is interesting. in itself without declaring any types beforehand. And if you take a look at the compile times of these things, these variables, the last one seems a bit different than the rest. Like the compile time says that it's an array of char, pipe, float, 64 in 32, and string. Like it combines all the possible types for you and infers that, which is super handful, and it kind of feels like a dynamic language, and it avoids a lot of boilerplate code. And the reason, yep.
For the array,
Mm-hmm.
is there a type of the order? Should it not be matching, or is
The order is, it doesn't matter.
should it not be char, string?
It's saying it's one of those.
Yeah, it can be one of those, which, yeah. I'm just going to talk about it in the next slide, which leads to this interesting thing called union types. And union types are a really unique feature of Crystal. Practically, what a union type is that the type of a variable or expression can consist of multiple types, actually. So the previous one was an example of that. Also, this one is like a pretty good example of how you can actually have multiple types returning from an expression. For example, when assigning to a same variable inside different if branches, you can see that at the end of the if, A will have the int32 or string type. And this reads that as the union of int32 and string. Like I said, this union type is created by the compiler. And the thing is that at runtime, like if you read this code, you see that A will, of course, be one type, which is int32. So the compile time is not necessarily the runtime type. Because, in dynamic languages, there is no such thing as compile time most of the time. But here, the compiler just infers all the possible types of the expressions so that it can allocate the best possible memory, best possible structure in the memory for you, or the most, resource light structure on the memory for you.
Oh, sorry. Could you explain, this seems kind of like an upgrade data type.
Mm-hmm. Kind of.
It just doesn't have a label to it.
Yeah.
Basically, so how close is that? Did that kind of come from that idea, or?
Kind of, like the creator of the language is actually inspired heavily by Haskell and all other FP languages who have algebraic data types. So that explains that. Continuing on, we have something called method overloading. If you ever use Java or any kind of compiled language before, you are familiar with this. But people coming from dynamic languages like Ruby and Python, they don't have that. Ruby doesn't have that. I wish it did, but hey. The thing is that you can have different methods with the same name and different number of arguments, and they will be considered as separate methods. And this is called basically method overloading. What I mean by that is that, let me show you an example in Ruby and you will get it. For example, when you're dealing with Ruby, if you want to have a method which handles different classes, like with different types of objects, it gets really ugly really quickly. For example, you see that if you want to handle my class array string, you don't have a specific way of doing that other than doing a case statement and then checking the types of each variable, which is not the best way to handle. And as you see, the method gets really long really quickly. The solution to that in Crystal is like this. So you can actually have the same method for different types, which means it's super explicit, and you can do all kind of abstractions for the specific type without actually mixing code. And the dispatcher is smart enough to understand that you are actually like dispatching to the correct signature. As you can see, the first one dispatches to my class version, and the second one to array, and the last one to string version. So if you have the types, it's pretty easy. And the thing is that Crystal is null safe by default. What I mean by that is that all types are non-nullable in Crystal, and nullable or nullable variables are represented as a union between the type and null. As a result of this, the compiler will automatically check for null references in compile time, helping prevent the dreadful billion-dollar mistake that took down a lot of companies. And this is like the daily life of a Ruby developer. I'm pretty sure if you are doing dynamic languages, it's always like no method error defined for nil class. And if you're using Crystal, you can't do that because the compiler is really strict and will let you handle all the nullable cases, and that lets you avoid the null problem. Let's take a look at an example. Here, for example, you can see that the rand2 method, which returns from 0 to 2, a random number from 0 to 2, in this if case, you see that if it's greater than 0, it will return a string. My string will be hello world. But what if it's equal to 0? Normally, if you run this code in Ruby, you see this, like, or no, you don't see this, but you get a runtime undefined method, uppercase for nil. But at Crystal, if you try to compile this or run this, you just see a compile time error that you can't do this. Like nil does not have an uppercase method, so you have to handle that case explicitly. If it's nil, you have to add a branch for that, which is great because it is like super obvious that you have an edge case that you didn't think. So.
Can you then still do something like method missing in active record?
Yeah, you can do that.
You have this facility.
Yeah, I'm just getting into that. So the answer to method missing and metaprogramming in Crystal is something we call macros. Crystal has a powerful macro system which ranges from basic templating and AST inspection to types inspection and running arbitrary external programs. But the thing is that it has to be very valid Crystal code in the end. So macros are methods that receive AST nodes at compile time and produce code that is actually literally pasted into a program. So it's code that generates codes for you, which is pretty simple explanation. Let me show you. So if you take a look at this macro definition, you see the curly braces. So this is a macro which defines a method for you. And the macro's definition body looks like regular Crystal code with extra syntax to manipulate the AST nodes. But the generated code is, in the end, a valid Crystal code. Here you see that we call the define method macro. We pass foo and say 1, and that's pasted into the body. So it creates a method named foo, which just returns 1. Of course, you can make this better, and you can handle edge cases, but this gives you the idea of what you can do with macro system. And the thing is that concurrency is hard, and also concurrency is not parallelism. And in Crystal, we use something called fibers, which is close to green threads, from other languages, but not the same. And fibers communicate with each other using channels. And that's pretty similar as in Go or in Clojure, without having to turn to shared memory or locks. So it's safe. However, fibers are, unlike threads, are cooperative. And threads are preemptive. The operating system might interrupt a thread at any time, which is bad, and start executing another one. However, if you are using a fiber in Crystal, you must explicitly tell the runtime scheduler that you need to switch to another fiber. For example, if there is I/O to be waited on, a fiber will wait on that and will tell the scheduler, look, I have to wait for this I/O first to be available. And meanwhile, you can continue executing on other fibers. So, and also, please come back to me and tell me that I'm finished with the I/O and I will continue. So it's like, it's explicit and it's cooperative. So just let me show you a quick example of that. So if you take a look at this code, we use the channel and we declare it at the top. We give the type that's passed between the channels. In this case, it's an int32. And this is actually a concurrent file size reader. As you can see, it just globs through all txt files in the folder. And for each file, it creates a fiber with the span keyword. And then it reads the site and passes back the size to the channel in an asynchronous way without blocking it. But the thing is that the fiber spawned for each file has to send it back to the channel. And in the end, you just get it like we calculate the total lines with the we use the receive keyword to receive it back from the send channel, and that's it. It may seem quite complex, but once you get the idea that you are just passing messages in between channels, it gets quite easy. And the thing is that it's super cheap. Like a fiber starts with 4K virtual memory and can grow up to 8 megabytes or something like that, which means if you are using a 64-bit operating system, you can create millions of fibers, and that would be okay. And Crystal compiles to efficient native code for the given platform. What does it mean is that, for example, if you compile it in a POSIX-based system, you will get the executable and you would run it like this. And if you're on Windows, which is still work in progress, if you compile, you'll get the exe and just run it like that. So native code, pretty easy to compile and pretty easy to run, which is a dream for a Ruby developer, by the way. And then, like I said, we don't want to write C code. And what do we do instead? We just bind to C code without writing C code. So let me show you a simple example. This might look a lot of code, but there is no C here. It's just you're writing binding to, for example, in this case, libgmp, which is a C library used for dealing with very big numbers with a lot of digits in it. And as you can see, we create a binding in Crystal to a C library without writing any C code. And the C bindings thing has a lot of tweaks and tricks to it. Like you can specify the package config, headers, LLVM headers, etc., etc. But in the end, you can bind to any C library, I think. And also test-driven development. I hope everyone is doing that. And we love testing our code. And Crystal has first-class support for TDDing. And the thing is that Crystal comes with a fully featured spec library. And it provides a structure for writing executable examples of how your code should behave. And this is totally inspired by RSpec, which is a Ruby library for testing your Ruby code. And as you can see, it's pretty close to plain English. Like you describe, you specify an it block and specify the behavior you expect. Pretty easy to understand. And we have other bonus stuff, which I like to show you, but I'm also running short on time, so I'll rush a bit. This one, for example, is pretty interesting, which is called Crystal Play. It's actually an interactive playground, which you can open on your browser. Like you type the Crystal Play command on your command line, and it creates a local instance on port 8080, and you just go to browser and you can play with this thing, create a workbook, save your code, share with others. As you can see, this is pretty much like an interactive shell, but if you think about a compiled language perspective, having an interactive shell is an amazing thing, because most of the compiled language, you need to compile the code first. In Crystal Playground, it's pretty easy to do that without actually, rerunning your code. You can just do quick and dirty, or actually, you can do a lot of stuff with this. And the next thing is the auto formatter that's built into the language. And that's also the ideas taken from Go, I would say. Because, oh my God, at Ruby World, we have this holy war between single quotes and double quotes. Is it like, do you have to use frozen string or not? So a lot of that kind of, redundant stuff, redundant talk is avoided by just having a formatter. Like, is it tabs versus white spaces? No, we don't have that kind of conversation. We use white space too, line indentation, and the auto formatter is a great way to run at your, CI/CD workflow, doing that for you. And also another great thing I would say is we have no global variables, and I think I don't have to say a lot about why we shouldn't use global variables, because they are evil, they cause concurrency issues, they pollute the namespace, and they are super hard to test because you don't know when it's modified. And I really suggest you to Google global variables are bad or evil, and you will see tons of articles on the first page. And the thing is that in the beginning of the slides, I said that we have 4.5K packages, and Crystal packages are called shards. So if you think about it, Crystal shards makes a lot of sense. It has a rhyme. And we pack the Crystal libraries as a shard, and we distribute via Git. Currently, we don't have a centralized thing like RubyGems or NPM or Cargo or whatever. It's just distributed via Git and some other source control. I think we also support SVN. And here's a declaration, like you can declare stuff like this in a YAML file, and boom, then you can use your dependency. And here is the, do I have time?
We actually are already over. You have time for maybe 2 questions, but we do have a break.
Okay, so let's have the questions later because we are running out of time. So this is the website that you can actually browse which packages are there, which shards are there. As you can see, we have more than 4.5K as of now. And you see the trending and latest stuff. I said computer friendly. I have some impressive benchmarks, but take it with a grain of salt, of course. So this is taken from this repository. You can go there and see other benchmarks. But the thing is that you get the idea. It's in between Ruby and C, and also close to Go, Rust, and goes in between. This is all.
Finish up in 1 minute. We're already through.
Okay. I'm gonna finish in 1 minute. So this is Kemal, performing good in Tech Empower Web Framework Benchmarks, round 15, I think. You can check it. This is also handling over 60K WebSocket connections in a single DigitalOcean 2 gig instance, which is impressive. And who's using Crystal in production? We have more than 30 companies using it in production, including AI companies, cybersecurity, biotech. You can check the wiki for that. We have an updated list there. And I'll just pass the future because, anyway, we have multi-threading in progress. Windows is also in progress. It's going good. And we are not 1.0 yet. Like I said, we are at 0.29. Resources, you can check the official docs, which is like a book-ish version. I wrote a small book, free book called Crystal for Rubyists. If you're a Rubyist, just go there. Or if you have used the dynamic language, just go there and read it. It's super simple and short. And there's an official book which just came out from PragProg. It's pretty good. Go buy it. And please join the community, Gitter, Reddit, forum, Twitter. It's pretty active. And that's it. Thank you very much.